So we're going to take this system and we are going to solve the system using elimination. So the very first thing that I want to do is I want to check to make sure everything is aligned. So I have all of my X's aligned. I have all my Y's aligned, and I have all my numbers aligned. If they were not aligned, then I would have to move them from one side to the other. So the very first thing that you're going to look at is to see what column can you eliminate? Can you eliminate, do you have a negative 8x and a positive 8x? No, you don't. So we can multiply both of them to become negative 48 and positive 48, or we can go over to the Y column and see I have a negative 10y. This is a positive 5y. I can make both of these a 10 and one be negative and the other one be positive, and then add those together. So the way that I'm going to make this middle number a 10y positive is by multiplying this whole equation by a number that's going to make this a positive 10. So since this is a 5, I'm going to multiply everything by 2 because this makes the middle number a positive 10. And the whole point is to eliminate a column. So I'm going to take 2. If I multiply the middle by 2, I have to multiply the 2 times the 6x, and then 2 times the 5y, which is 10y, and then 2 times 2, which is 4. So I took the number 2 and I multiplied it by everything in this bottom equation. Next, I'm just going to rewrite my top equation, and then I'm going to add them together. So you can see that you have a negative 10 and a positive 10. So those are automatically going to cancel out now. So the whole point was to eliminate those. Then I have a negative 8x plus 12x. So that's going to give me a positive 4x equals, I have a 24 and a 4. So it's going to be 28. So I'm going to divide by 4, and my x is going to equal 7. So now that I have my x value, now I have to figure out what the other variable is, which is the y. So I can take the original equation, 6x plus 5y equals 2, and I can plug in this x right here. So 6 times 7. So instead of putting the x, I put what x equals, plus 5y equals 2. And 6 times 7 is 42. Plus 5y equals 2. I would subtract that 42. But you would subtract it from both sides because you're going to solve the equation like you would solve any other equation. So I have a 2, and then I have a negative 42. So that's going to give me a negative 40. Then I divide by 5, y is going to give me a negative 8. So my answer would be 7, negative 8. If I wanted to check this to make sure that it was correct, you can plug it in to the equations. So if I plugged it into the original equation, my original equation was 8x, but instead of an x, I'm going to put 7. So all I'm doing is checking. So I'm just checking my work. So I'm going to plug in this. I'm going to plug in the X and the Y. So I have -8 times 7 minus 10 times -8 equals 24. And all I want to do is make sure that the left side, that this side equals this side. So I would do -8 times 7, which is -56, plus 80, because a negative times a positive is a positive. And when you calculate these, this equals 24. So if I simplify the left side and it equals 24, and the right side says 24, this means that my answer so far for this equation is correct. So that means that works for this equation, but now you have to check the next equation. So you would just rewrite the next equation. So 6x plus 5y equals 2. Instead of the x, I plug in a 7. Instead of the y, I plug in a -8. And we want to see if this side equals 2, like this side does. So we have 42. We have plus 5 times -8. So that's going to give us a -40. So if I simplify this, 42 minus 40, that's going to give me a 2. And a 2 equals 2. So that's good. That means that my answer here, when I plug it into both equations at the very end, it makes one side of the equation equal the other side of the equation. So that means that your answer is correct. So that's how you can prove that your answer is correct.